Guys, in this video we are going to see an example of magnetically coupled circuit. Here we are going to find I1 and I2 mesh currents, but before we go and do this problem, let's see how does this dot works. First we have to understand that one, then it's going to become easier. Okay, now let's draw our circuits. Okay, let's say this is one of the circuit, this is the other one, and we have the inductor here, inductor in these two. Okay, inductor here, and then we have the dot here, right? Dot here. So if the dot is on top of the inductor, it means current is going along this direction. So you have to always look at the dot and the current is going in this direction. For this one, it's going in this direction. Okay, so this is going to be plus and this is going to be minus. And if you assume, like for example, if we have the dot on bottom, if we have the dot on bottom, the current is going to flow through this one. Okay, that's all you have to know. And if the dot is here and if you put your mesh current in the opposite direction, let's say you put I2 in this direction, you are going to have negative I2 because you are assuming the opposite direction of this dot, so we are going to have opposite sign, right? So it's always better to keep the direction along this dot. In that way these kind of problems will be easier. So that's all we have to know. Now let's go ahead and do this problem. Okay, let's get rid of this part. And since we have the dot, both dots are on top of this inductor, we are going to assume the direction of the current in this direction. Okay, this is our I1 and this is our I2. These are the two things we are trying to find. Now here we are going to use the Kirchoff's voltage law. KVL says that voltage in is equal to voltage out. In our case, voltage in is equal to 12 0 degree KVL, and that one is equivalent to negative 4j I1, and then this is going through the 5j I1 plus 5j I1, and we have to look at the mutual inductance. This is our mutual inductance. And when you look at the mutual inductance, you have to look at the opposite one. Okay, when you consider this loop, you have to look at the mutual inductance in the other circuit. In other one, this is along the mutual inductance direction, the dot direction, right? Along the dot direction, and the mutual inductance is 3j, so 3j I2 positive because of the direction we assumed. So this is going to be 3j I2. This is going to be the KVL equation for this mesh. Now let's try to simplify this one. Negative 4j plus 5j, that's going to be just 1j, ji1, and we are going to have 3j I2 and 12 0 degree angle. Okay, so this is going to be our first equation, equation 1. Now we are going to apply KVL for the other one, KVL for this loop, and I2 is entering this 6j, so this is going to be, since we don't have any voltage source, we are going to equate addition of all the voltage equal to 0. Okay, that's another way to express KVL. Now this is going to be 6j I2, then this I2 is entering this 12, so this is going to be plus 12 I2, and then mutual inductance. Now you have to look at the mutual inductance in this circuit. Since we assume the same direction as this dot, this is going to be plus 3j I1, plus 3j I1. Okay, and that's equal to 0, and that's all we have to know. Now let's see whether we can add something. This is already in good shape, right? So we can leave it like this, and then we can go ahead and solve for I1 and I2. So in order to do this one, we can create matrix. To create matrix, I should have combined I1 and I2 together. Okay, here we can take I2 common. If I take I2 common, this is going to be 12 plus 6j times I2, then plus 3j I1 is equal to 0, and this is going to be the equation number 2. Okay, so this is equation 2. Now we can go ahead and create our matrix. In the matrix we are going to have I1, we are going to put the I1 values first. In the first one we have J, and I2 is going to be 3J. In the second one we have I1 is 3J, right? I1 is 3J, and I2 is 12 plus 6J, 12 plus 6J. And after that we are going to put 12, and here we are going to have 0, and that's it. Now we have to solve this I1 and I2 using Kirchoff's, not Kirchoff, we had to do the determinant. And if you remember, first we have to find the determinant of this one. Okay, to find the determinant, since we have 2 by 2 matrix, if it's A, B, C, D, you have to do AD minus BC. Okay, AD minus BC, cross product of, like, cross of this one minus BC. So that's going to give us a determinant, and if you calculate for this one, you are going to get, let's call this one del. Del is equal to 12J plus 3. Okay, now this is the determinant for this one. Now we have to find the determinant for this one. We have to switch with the first column to find out I1. We have to switch this one with first column and find the determinant. And if you do that, you're gonna get 144 plus 72J. Okay, the first column, like if you switch this one, the matrix is going to look like this: 12, 0, then 3J, 12 plus J, 12 plus 6J, then you do the AD minus BC, you will get this one. Now del 2, you have to do the same thing for this one. You keep the other one, 3J remains the same, then you change this one into 12, 0, then you find the determinant, and that's going to give you negative 36J. Okay, so this is the Kramer's rules we are going to use. Okay, so we have this one, these three things available. Now we can go ahead and find out our I1 and I2. And Kramer's rule says you can find I1 by putting this del 1 on top, 144 plus 72J, and dividing by the original determinant, that's 12J plus 3, and that's going to give you 8.47 minus 9.88. This is in rectangular form, and if you want to convert, if you convert this one in polar coordinate, you are going to get I1 is equal to 13.01, and the angle is going to be negative 49.39. Okay, so this is our I1. Now to find the I2, you have to do the same thing, like you have to put the del 2 on top. I2 is going to be del 2, that's negative 36J, and then you have to divide this one by the original matrix, that is 12J plus 3, and if you calculate this value, you are going to get negative 2.82 minus 0.705 J in polar coordinate. No, this is in rectangular coordinate, and if you convert this one into polar coordinate, you are going to have 2.91 and negative 165.96 degree. And that's how we do this kind of problems. I hope this helps. Thanks for watching.